Hi guys, so welcome to week 3. As per usual, let's go ahead and create a new project. Okay, so this will be, we are in module 1, week 3, call it whatever you like. And I'm going to save it in my D drive. Okay, accept on that, and then save, always save your HIP file. So what are we, week 3, version 1. Great, so yeah, this week is all about volumes. So I'm just clearing up my desktop there, by the way. If you want to do the same, just delete those at the top, but you can work however you like. Now I'm going to create a geometry node. Let's call this volumes intro. So we'll just have a quick look at some volumes. So typically in Houdini, if we've just dropped down a test geometry pig head, we haven't looked at these, but they're kind of handy. If you again, tab on your keyboard, start typing test, and you'll see you've got all these different pieces of test geometry. You've got this crag, which has some animation and a rig, I think. Got a pig head, rubber toy, which are both just models, static with textures. Your shader ball, this squab, this weird alien thing, loads of cool stuff. So we're going to work with this pig head, but I'm going to turn off the shader. I don't want that, and just leave it on the medium. So yeah, typically in Houdini, or well, in any software package, you're working with primitives and points or vertices. In Houdini, points and vertices. And they kind of, they don't occupy 3D space, really, they represent space. So each point, each primitive is infinitely thin, it doesn't have any thickness. Each point is infinitely small, it doesn't occupy any volume. But a volume does occupy volume. So how do we make a volume? So a couple of options. We can use the older or less efficient way, which I wouldn't recommend using, but worth talking about, is ISO offset, which will create the native Houdini volume. So connect that, and then right away you might be able to see that. If not, press D on your keyboard, turn your background dark, and then we can see something that kind of looks like a volume. We can increase this volume, the sampling division, so you're just kind of dividing this and giving it more detail, basically continuous to 100. There we go. So you can see there we've got different levels of density going through this. Okay, and then if we take a look at the information, we've got 1 point, 1 primitive. We've got this new thing, 1 volume here. And you can see there the quantity of voxels and how many voxels in each axis. Okay, so that's one way of doing it. Another way is to use something called a VDB from polygons, if we can find it. There you are. Okay, and then if we visualize that, get something that looks really weird. We'll talk about this in a minute, but for now, just turn off distance VDB and turn on fog VDB. We've got something more, something similar. The way of splitting this up is not the same. So here we need to lower the value. It's a bit like a particle separation. So the lower the value, the more detail we have, but that gives us a similar result. So what's the difference between a VDB and a Houdini volume? So basically a VDB is more, I'm not sure what VDB stands for, but it's it's basically more efficient. So the way that we can see that, if I drop a wrangle, so a volume wrangle, so don't worry too much about what this does. It's just a way of writing code onto volumes. Now, so here we're creating a density attribute. You can see that. Okay, and we can raise or decrease that. So to access that, I just write density, which is the name of the attribute, and then I can set it to 2. and that will make it all darker there. You can see 2, 3, or I can lower it. I can set it to 0.1. Okay, which makes it pretty much disappear, maybe there. Okay, now if I do the same over here, you'll see something different. Aha, we get a big box. If I set that to 1, I'm getting an error there for some reason. I think because, yeah, we don't have a name there. If I change this to density, there we go. So now we're getting a box. So the reason for that is that the Houdini volumes creates a box, a kind of bounding box around your geometry and fills that with a volume. And basically, you know, wherever there isn't geometry, we've got 0, a value of 0, and everything else has, you know, values of whatever you want. However, the VDB just kind of discards any empty space. It doesn't contain voxels. So this is much more efficient in terms of memory. It's worth talking about Houdini volumes because when you're working in Pyro or in simulations, we're still using Houdini volumes within the simulation. So when you run a simulation, what you'll get out of that is a Houdini volume. So you may want to convert it to VDB if necessary. Normally it's not necessary, but you know, they basically work in a similar way. It's just when you're working on geometry or kind of static things, not simulating anything, just stick to VDBs is what I would do. So a volume can hold different types of attributes. So here we've just got density, but it can hold more. So we could, if we wanted a vector, if we add a point velocity node, okay, we'll add some velocity. Again, I'm just demonstrating here. Don't worry about, you know, velocity is just movement, a vector which demonstrates, which indicates movement, you know, velocity. So here I'm just going to drop this point velocity, add a curl noise. If you come here to this visualizer, display point trails, that shows us the velocity. And if we just increase the scale just so we can see it, and maybe if I decrease the swirl size, increase the swirl size, so you get a sense there we've got this kind of curly movement. So in a simulation, this would mean that, you know, this, if these were particles, maybe these would go this way. The eye would they would follow these lines, right? But this, I just want to show you here. If we come to the points, we've got a vector there which represents the velocity, and this we can store that within the volume as well. So if we come here and press plus, and if we select this point V, now you can see something changed there. So that's because the display the viewport is trying to display this velocity. It doesn't really do a good job of that, but we can do that in another way. We can use a first of all, if we use a volume slice, okay, connect that up down here. So that's kind of taking a slice through the geometry and looking at the density in this case. Well, we can specify that's just the density there. But if we take the velocity, delete that, and then grab a volume trail. Sorry, the volume trail requires points. So we've got we're creating points here, and the volume itself. Then we should start to see, yeah, some trails. Okay, so you can see there, these are these kind of visualization of that velocity. So obviously, you know, we can just see them here, but if coming out of a simulation, sometimes this is a useful thing to do. If you have a velocity or you're generating a volume velocity to go into your simulation, this is a handy thing to do. Another way of doing this, if we take a VDB visualization tree, connect that up there. So what this is showing us is, you know, that's the extent of our volume. You know, we have some padding on the outside and the inside, which is something we'll come back to when we look at distance VDBs. But this is another handy way of kind of visualizing your volumes. But I'm going to generate some points here, turn off these tiles there. Okay, and then connect that up, and this is a cool way of visualizing your velocities as well. There we go. So there you can see, it's kind of cool in itself, what those velocities look like. So it's worth also talking about, if we come here, this surface VDB. Okay, let me actually, I'll turn that back on and just drag this over. And I don't want the velocities on there. I don't think it should matter. I'm going to turn on this surface and get rid of that. So now this looks kind of different. So this is another VDB. You can also do this with Houdini. But again, it's, you know, I wouldn't recommend it. Change this to SDF volume. So they've got a different name, but it's the same thing, an SDF volume or a surface, which is is an SDF. The surface is just the name. You can change this to whatever you want. So this kind of looks different. You can see kind of looks like a surface. So this is a great way of working on geometry, basically. So instead of, we wouldn't use surface volumes for any kind of simulation. You may. I've not done that myself, but this is a good way of working with kind of organic, you know, creating rocks and fixing problems with geometry as well. It's really handy for that. If I kind of demonstrate, if we just take a transform and a merge, this is something I do. Oops, not file merge, just a normal merge. Grab that. I merge the two together, and then if I do something just like that, you know, you've got intersecting geometry, you know, it's very, very messy. If I connect that up, they kind of blend together nicely, and you can see on the inside it's kind of made that hollow for me. Kind of hard to see, but if I do it like that, you can see we've got a hollow space on the inside, whereas here I've got polygons in my face. But then what you can do is convert this back to polygons, and it will give you a nice mesh. You can see these are connected now, and we've got a hollow space on the inside, which is a really nice way of creating geometry, fixing problems with geometry as well. One thing to be careful of is when you are, let me take this, I'm going to alt click and drag and make a different one here. Okay, because I want to make this hard, and that way it's just an open piece of geometry like that. We've got a hole. And normally that's a bit of a problem, you can see. You know, it requires a closed surface typically. But what you can do, you know, you can either try to, you know, just drop a polyfill, which will plug that hole for you, or generate this, or you can poly extrude. Also, just kind of give it some thickness and make sure you check output back, and that will also work. Another option is to, take your VDB. So it looks like there's no information there, but there is something there. And if we take a VDB, a reshape, SDF, that's it. Okay, and just connect that up. You can see it says dilate, so that's kind of dilating, kind of swelling or inflating your volume. And if I start pushing that up, you get something like that, which is another very useful case. Something I use VDBs for also is, you know, making groups by swelling geometry like this. If you do that with polygons, they kind of, you get some weird results sometimes. So yeah, that's we'll come back to these later, but first of all we're looking at clouds, so we're going to be working with these nice soft wispy clouds.